Okay, so the general approach to doing any type of conversion from one unit to another is the following. You're going to first determine what you're given, and that's always going to be a number with a unit. Then you're going to determine what is the new unit that you want to convert into, and that's always going to be given in the problem. Once you determine that, you have to find a conversion factor that has the same two units involved. For example, here we have meters and inches. So I need a conversion factor that tells me how many inches are in how many meters. And so I went down here and I find out that there are 39.54 inches in 1 meter. I use that conversion factor to set up a equivalency problem. So it's just a bunch of ratios that are multiplied together. So the ratio here is 2.43 meters over 1. We always put it over 1 as a placeholder, is to 39.4 inches to 1 meter. So what's going to happen is when I do this math and I multiply these two fractions, the meters are going to cancel, and I'm going to be left with inches on the top. So again, the meters cancel, and then I'm going to be into inches. And so if I do that math, it says that 96.1 inches is the same dimension as 2.43 meters. So it's basically, that's how we're going to work it out. And I'll show you how we do it on the next page. Okay, for chem, we are going to only have a couple of conversion factors that we care about in these chapters. One is everything, remember, everything's based on the mole. So the mole is equal to the molar mass of something in grams. So whatever the molar mass is of, let's say, hydrogen chloride, if I weigh out that many grams of it, I get 1 mole. The mole is also equal to 6.02 times 10 to the 23rd representative particles. Now, a representative particle means it could be an atom, a molecule, particle, formula unit, whatever, right? It's whatever the thing is, there are 6.02 times 10 to the 23rd of these things. So if we're talking about the element of aluminum, there would be 6.02 times 10 to the 23rd atoms of aluminum. If we're talking about water, it would be 6.02 times 10 to the 23rd molecules of water. If we're talking about sodium chloride, it would be formula units. All right. Now we can always write it a bunch of different ways. 1 mole over the molar mass is equal to 1 molar mass over 1 mole. The same dimension. 1 mole equals this number of grams of something. Therefore, this number of grams of something also equals 1 mole. So they're the same. They're just inverted, right? And then also 1 mole is equal to this number of particles, and this number of particles is also equal to 1 mole. Now, if you look at it here, obviously the molar mass is equal to a mole, and 1 mole is equal to this many particles. Therefore, if I weigh out a molar mass of something, I get that many particles. So we're going to use these conversion factors to help us solve conversions between grams and particles and moles. Okay, so let's see how we're going to do this. The first thing we're going to do is we're going to figure out what is our given and what is our thing. So I'm going to write given here, and then what we want. And then we're going to circle each one. So my given, again, is 22 grams of argon. So that would be my given. And then what do we want? We want how many moles? So that's the want. All right. Now, the next thing I got to do while I'm looking at this problem is I've got to figure out what is my conversion factor between moles and grams. And I know that 1 mole is equal to the molar mass, and we're going to abbreviate MM as molar mass in grams. Okay, so now I know what type of things I'm going to need here. I need to find the molar mass of what? I need to find the molar mass of argon. So I'm going to look that up in my periodic table. Now the given, I already know it is, and now I can set up my problem on the next page and get everything solved and do the conversion. Okay, so when we do this, we always put the given amount, it goes here. And then the want will go here. Let me show you what I mean by that. So the first thing we're going to do is when we do this, my given is 22 grams of argon again. So I'm going to put that right here. And I always put that over 1. Now, before I do anything next, whatever the unit is here, grams, I need to put that unit here, because they're going to end up canceling each other in a minute. Now, what do I want to find? I want to find what? Moles. So that unit goes here. Now, I know what I need to put where. So remember back to the thing I said that 1 mole equals the molar mass in grams. So when we do that, what are we going to get? We need to look up the number for argon for molar mass, and we'll do that on the next page. Okay, so I looked up the molar mass of argon, and it's 39.95, which is pretty close to 40, but we're going to use the 39.95 because you always want to carry it to the second decimal place. All right, so the expression is the number follows the unit. So what number goes with the word moles? And the number is a 1. So we're going to put a 1 there. And I'm going to tell you that most of the times that number is going to be 1 when you see the word moles in these types of problems. Now, what number goes with grams? And then we can see it right here. There's the number. So the number goes there. That is your conversion factor. Remember, 39.95. Now it's just a math problem, right? We're going to multiply everything on the top, 22 times 1, divided by 1 times 39.95. Now remember, the tops, it's like these are like multiplying two different fractions together. So if you were to multiply like 1/2 times 3/4, that would equal 3/8. Right? You're just multiplying a bunch of fractions together. So these lines here, these just separate the fractions, and every time you see a cross line like that, you're going to say that means I'm going to multiply those two boxes together. And then this line right here is just the fraction line, right? So it's basically like you're multiplying two fractions together. And that's all you're doing. All right, so now when you get the answer here, you're going to get 0.55 moles of argon. Now you might want to say, why isn't it grams? Because the grams cancel because there's 1 on the top and the bottom. Okay, so let's go the other way. We're going to go now from moles to grams, right? Because it says how many grams are in 88.1 moles. So what's my given? My given is 88 moles. So that's there. And what do I want? I want number of grams. And that's from there. Now I need to have my grams to moles conversion. So I'm going to need that 1 mole equals the molar mass in grams. So I got to look that up. And then let me show you how it sets up on the next one. Okay, so step 1, we're going to determine given and want and fill in the appropriate boxes. So what am I given? I'm given 88.1 moles. So 88.1 moles. And then the word moles goes here. And then the number 1 goes here. And then what I want grams. And then, so now I know what I need as far as a conversion factor. I need something between grams and moles, and I know what that one is. That says that 1 mole equals the molar mass in grams. So now I just have to look up the molar mass of magnesium, and now then I can make that conversion. Now that we have everything filled in, now we just have to put the correct numbers where they go for the conversion factor. And remember this, I said the number follows the unit. So what number goes with the word mole? And that's the number 1. So we're going to put here 1. Notice before it was on the top, but now it's on the bottom because we're going the other way, right? And now what number goes with the word gram? And that's 24.3. So now we have just a simple math problem now. We're just going to multiply these two numbers together and then divide by 1 times 1, which is 1. So we don't really have to divide by anything because anything divided by 1 is just that number. And so we just got to multiply those two together. And when we do that, we get 2,141 grams of magnesium. Now, does that make sense? Because we got to cross out the moles. Does that make sense? Sure it does. Each mole weighs 24.3 grams. So if I have 1 mole, I have 24.3 grams. If I have 10 moles, I have 243 grams, right? If I have 100 moles, I would have 2,430 grams. But I don't have quite 100 moles. I have just 88, so it's less than 2,400, and so that makes sense. So it looks like we did it right. Now all the steps that we've done before are exactly the same, except now we're going to be converting from particles to moles. All right, so let's see how we do that. So again, we're just going to circle what we were given. We're given this. That's my given. And then what do we want? Well, this time we want atoms. How many atoms, right? So that's a different unit, right? So now I know what we want. And now I need something between atoms equaling moles. Now I know what the conversion factor is. There are 6.02 times 10 to the 23rd atoms, or representative particles, in 1 mole of material. So I can use that when I set up the next equation. Okay, again, we're going to just basically put in the information we know. We need 6.3 moles of Al, and that's over 1. And what are we trying to find? We're trying to find moles. Or we're not trying to find moles, I'm sorry. We're trying to find atoms. So that's on the top here. And now, again, we know which one we're going to use. It's 1 mole equals 6.02 times 10 to the 23rd atoms. So now we just got to fill it in when we get to the next slide. Okay, so we've done the same thing before, except now we're just going to use atoms and moles. And so what is the number that goes with the word mole? And again, that's a 1. So that's what we're going to put there. So that's 1 mole of aluminum. And then how many particles? Well, there's my particles 1, so I have to put that number here. All right, now we are in business. Now it's just a math problem. If we do the math here, we get 3.79 times 10 to the 24th atoms. There you have it. 3.79 times 10 to the 24 atoms are in 6.3 moles of aluminum. We know all the... Okay, so what are we given? We're given this number right here. So that's my given. And then what do we want? And that's that there. So we want moles. And so when we need something between molecules and moles. So we know those numbers, 6.02 times 10 to the 23rd molecules. Remember, molecules are representing a particle, is in 1 mole. And there's the 1. So we're done. So now we have all the information we need to solve the problem. All right, so our given goes here, 5.68 times 10 to the 23rd, and that's molecules. And then we put molecules here. And then, what are we trying to find? We're trying to find moles. And then don't forget to put this over 1. All right, so now we've got all the stuff that we need. Remember, we have the 1 mole equals 6.02 times 10 to the 23rd molecules. Okay, so now that we have all the information and we filled in our boxes, now we can just fill in the conversion boxes where we need to go again. So again, what number follows the number follows the unit, so what number goes with the word mole, and that's a 1. So we're going to put the 1 the 1 here, and then what goes with the molecules, and that's the 6.02 times 10 to the 23rd. And now it's just a math problem again, and when we do this, we get 0.944 moles of water. And that makes sense because here we have 5.68 times 10 to the 23rd, and here we have 6.02, which is a larger number than this. This is larger than this. So therefore, if this is equal to 1 mole and this is smaller, we're going to have less than a mole. And that's what the math tells us. So in chemistry, the mole is the main conduit for all things. Everything goes through the mole. So if we start with mass and we weigh stuff out in mass, and we want to know how many particles that is, we first have to convert to moles, then particles. So this would be a mass to mole conversion, and then this would be a mole to particle conversion. So you've already done this step, and you've done this step. We're just going to combine the 2 steps together now. So particle to mole, and then let's say mole to mass, right? This volume STP, don't worry about that. That's for ideal gases, and we haven't started them yet. So what we're going to do is every time you go into the mole, you always divide. Divide by the molar mass, or divide by Avogadro's number. When you come out of the mole, you're either going to multiply by the molar mass, or you're going to multiply by Avogadro's number, depending on what you're doing. All right? So this is going to be a 2-step process, so it needs 3 picket fence segments. Okay, so here's how it goes. I'm going to do this really quickly. So we're going to find out what we're given. So here's my given, and this is what I want, grams. All right, so we're going to set it up. So the first thing we've got to do is we've got to set up our picket fences. So the first picket fence is what we write, and then the second one is to convert to moles, and then the third is to the want unit. So the way I go give this is given, this is moles, and then this is want. Right, so whatever you're given, those units go here, then we convert to moles, and then we convert to the want unit. So here's how it works. What are we given? We're given 3.7 times 10 to the 24th formula units of, so I'm going to call FU, I know people, I'm going to laugh at that, of NaCl. Okay? And then we put that over 1. Now, since we have formula units there, we have to put them here, formula units. And what do we have to convert to? Well, that is the word moles. Right? Now, if you were to do this half right here, you would convert the formula units to moles. Now, if you were to do this half right here, you're going to convert from moles to what? you're going to convert to grams. Right? And if you do that, then the moles goes down here. So now we just have to figure out, we're going to use both of those conversion equations. 1 mole equals 6.02 times 10 to the 23rd formula units. And then 1 mole also equals the molar mass. Right? And I gave you the molar mass right here. The molar mass of sodium chloride is right there, so you have to look it up. So now we can just start putting in the numbers where they go. All right? So the moles, right? How many, what's the word that follows moles in the formula units? So that's a 1. And then the formula units, by definition, that has to be the 6.02 times 10 to the 23rd. All right? So that's moles and formula units. Now we go back over to this one right here, and we have to write in the correct numbers for that. So 1 mole, remember the number follows the unit, is 58.5 grams. And now it's just multiply and divide like we did before. And if you do this, you get 359. I'm going to put that in a different color. Let's put that in yellow. 359 grams of NaCl is in that many formula units. All right, so I've walked you through all these the way to do it. All right, so now you should have no issues on your homework where you're going from grams to moles, moles to grams, particles to moles, particles to grams, and moles to particles. So good luck.